Hi, welcome to my presentation video. So let's talk about why. Why did I pick this topic on computer science STEM toys? I just want to share a personal story. When I got accepted to University of Waterloo to study engineering, first year engineering, they taught us a course called Digital Computational Logic. And I never had any programming experience before that, before my undergrad. So I have no idea what computer science is. And it was really hard to grasp the concept, the knowledge, without any foundation. And with that, a lot of students who do have experience programming are way ahead of me as compared to the students who didn't, like myself. So I think it's just very important for people to really get familiar with computer science and programming and at least know the basic. Just like math and science, and, people could do the basic addition, multiplication, division, but why not the basic computer programming? And another thing is that I'm a millennial, and the generation before me, they're called a Generation X. And people who are millennials, who are Generation X, they grew up in an era where computer science, computer programming isn't as popular as it is today. And so these people gonna end up become parents and they have no idea what computer science is all about. Then they don't have the knowledge or the motivation to go out and purchase computer science STEM toys for their children. The good thing is that it is predicted that in 2018, 51% of the STEM jobs are projected to be in the computer science related field. So, the STEM employment is on a high demand, and people are starting to pay more attention to computer science, which is a good thing. Solution. A lot of solutions were generated through primary and secondary research. That's from reading news articles, research paper, to going to Target toy section or Toys R Us, talking to parents, majority mothers, and understand why these parents are buying certain toys. Is it based on price, based on their educational background, and then also observe children's facial reaction, how they react when they see certain toys that their parents bought them. So what I notice is that children like to play with toys that have strong theme or character. They like to play with toys that, Batman, Iron Man, the stuff they've seen on TV, so you remind of their visual experience. So toys should be designed with characters, and I think it's a good idea to let the media tell the story instead of creating a story itself. STEM toys that focus on computer science need to be intuitive. Computer science is complex, but we're talking about toys right now. And toys need to be fun and entertaining. So it cannot be challenging or difficult to play with. So it should provide a certain kind of hints, guidelines, or very simple set of rules. The good thing is that there's a strong correlation between computer science and math. As I mentioned before, a lot of parents like to buy STEM toys that are focused only on math or general science that are either astronomy or biology. So when it comes to computer science STEM toys, it should incorporate math within as well for parents to see the relation between computer science and math. Last but not least, STEM toys that are educating computer science should be fun, should be cool looking. If it's not fun and cool looking, then it's like a calculator. It's only a tool. So it had to be very interesting for children to play with. How did it arrive? I did that just by asking a lot of why, a lot of questions, and find out the decision factor. And through that, I realized that the target audience for selling STEM toys or any toys, it isn't the kids, the children, it's the parents, because at the end of the day, it's the parents that had to go out of their way and go purchase these toys. Another thing is that STEM toys are very expensive. So if parents don't understand how the device or this STEM toy works, they're not going to invest a lot of money to purchase these things. So the STEM toy need to show how it's able to educate their children through a play interactive experience. Another thing is that a lot of parents have lack of understanding. So we need to find an alternative way to design and market computer science toys to parents instead of just telling them that it is important. Key points. Parents are willing to invest in more expensive educational toys because it's beneficial for their children. But they need to understand what they're purchasing. They were only willing to invest more expensive stuff for their children if they understand the whole story, the function, the concept, and the teaching process of the STEM toy itself. Because STEM toys is so expensive, children are not the one who go to store and spending hundreds of dollars purchasing these toys. So it's the parents who are the target customer. Ideas. Parents are the one who are purchasing these STEM toys, and children are the one who are playing with these STEM toys. So when it comes to the design, the theme should relate with both parents and children. Another thing is that children don't really care about STEM toys. They like to play and have fun. So the STEM toy itself should provide a play experience just as good as regular toys. Journey. The first step was secondary research, that just going online, read as much article as I possibly can. Some of the helpful ones were research paper on children development, either physical or mental. The mental one is really fascinating, where I able to understand at what age children are able to sort, uh, categorize, count, and these are the certain skills that need to be developed before children start playing with STEM toys. The second part was doing primary research, where I went to toy stores, Toys R Us, Target, to talk to some of the parents and understand why they buy certain toys and why they don't, what kind of investment they will put in for their children, and what is important for them. Then after I used my primary research data and my secondary research data to create an affinity diagram. And what the affinity diagram does is allow me to think more laterally than linear. And with that, I've gained a lot of insights on how to build uh, a market strategy through either market communication design or product design. Journey. First part of the design and the journey of this whole entire project was the secondary research. That's me going online, read up a lot of on children development. Majority of it is how they develop mentally, and within some of the research paper, you able to find out at what age they're ready to do certain mental task, as in distinguish the difference between colors, how to count, how to sort stuff, how to categorize stuff. So these are the certain fundamental development they need before they play with STEM toys. Next part was the primary research, where I went to different toy stores such as Toys R Us or Target to do person-to-person research, where I'm able to talk to a lot of parents, understand why do they buy certain toys for their children, and why does their children like certain toys and they don't. And also kind of observe how children really react in certain toy section areas. The next part of research is to look for different companies and kind of see what strategy they applied, either marketing strategy or design strategy. And Lego is one of the best STEM toy company out there. They started in the 30s, so parents and grandparents, they all have heard of Lego or played or have experience with Lego, and that's just create an instant trust, customer, and also customer loyalty. And how Lego market themselves is very intelligent. They create movies where children will go to the theater and watch, and then they will purchase these toys. And also, when you go to toy store and look for Lego toys, every Lego toy have certain kind of theme or resemblance of was showing in the current media. So there's Star Wars, there's Batman, there's Iron Man, there's all sort of themes that children can relate to and have seen before. So with all this research, the data that I collected, I put it into a affinity diagram. And what the affinity diagram does is allow me to analyze these data and think more laterally than linear. And with lateral thinking, I'm able to come up with certain ideas, either market communication design or a product design. Final solution and product design. In this section, I will show some picture where you're able to illustrate what the product is made of and its functionality. You will follow with an app design and a rendered video. Everyone have heard of or played with Pac-Man video game. To keep this design gender neutral, I incorporate Iron Man for boys and Hello Kitty for girls. This is my STEM toy design. The walls are constructible, so children can build their own maze. This is the starting position of the Pac-board. It has a digital score display, a Bluetooth button where it's able to connect with the Pac-Man and the tablet, a go button to start the Pac-Man, and a stop button to stop the Pac-Man's movement. This is the complete platform. The goal of the game is to collect all the 25 Pac dots before it reach the complete platform. This is the exploded view of the Pac dot. It consists of a translucent light cover, a 10-watt LED light, and a touch sensor to turn off the LED light when the Pac-Man is across over. This is the Pac-Man. As you can see, the LED light is turned off, showing that the Pac-Man have consumed the Pac dot. The Pac-Man consumed 6 Pac dots. You can see this on the digital scoreboard. App prototype. This part of the video will explain how the app works and show the learning process. This is an app I developed. Right now, just a prototype. There's 3 different options when the user open up this app. There's beginner, intermediate, advanced. The purpose of this is to have like a learning process. So the beginner is just a regular remote control RC toy that children are able to remotely control the Pac-Man vehicle itself, either move forward, turn left and right. And the purpose of this part is to make it like a fun experience and entertaining experience for children to play with this toy instead of jumping right into intermediate level or the advanced level where children have no idea what computer science, computer coding is. So let's check out the beginning, remote control. It will take you to this, you will take the user to this page. There's a button that the children could press, which is move forward, allow the vehicle to move forward, and if the user want the vehicle to turn left and right, they can use this adjustment knob to turn the vehicle left and right. And yeah, so this is exactly like any RC toy where the user is able to control the vehicle back and forth and left and right. Now let's check out the intermediate level. So now let's click the intermediate level. It will take them to this page. Command option is just giving options on the vehicle itself, move forward, turn right, turn left. Let's say we want the vehicle to move forward. We'll click forward and it will ask the user select number of Pac dots, as in the distance you want the actual vehicle to move. Right here is a square stencil, so it will give the user a hint that instead of picking the circular buttons, they will pick the 1 to 5 square ones. So let's say the user want to collect 3 of the Pac dots in front of them. They will click 3. 3 will show up right here, and the app will ask the user, what is the next move? Let's say the user's next move, they want the vehicle to turn right. So click on right, and because turning is a rotational thing, it doesn't have any distance, you only have degrees. Right here, the stencil is circle. So the user would pick the circular ones instead of the square ones. Let's say we want the vehicle to rotate 180 degrees, we'll just press 180. And so this is just a way to educate children on how instruction works when it comes to programming robotic stuff. That is just one comes after the other. When the user is satisfied with the program, they could press compile. On the right side is check out the advanced code. So let's check it out. The advanced code. This part is more resemblance to C++ code instead of this ladder logic. These two are exactly the same. So when the user are in the intermediate level and they do this stuff, this is what's really happening into the computer program, and that's why it's in the advanced level. So when the user wants to understand and see what's going on, they can click on the advanced level and they can take a look how the program is actually working. So let's say the user is satisfied with just these two tasks. They will press compile. The program will compile and it will say push the go button on the backboard after compiling. Let's go back to the home page and check out the advanced level. Click on the advanced mode and it will take the user to this page. The purpose of these codes are to educate and as an example to allow the user to understand how if and else statement works, which is right here, if and else statement, and how the while loop works. And the text in green are comments, and these comments able to tell the user or children how each individual syntax or statement really mean and what does it really do. So let's say for an if statement, if button go is pushed, then you want the Pac-Man to start. Else, if this did not satisfy the if statement, it would do nothing. And that's how the if and else statement works. While loop. While button stop is not pushed, and this is very important, pack dots, the variable, is less than 1, then you want the robot to move forward. But if any of these two constraints did not satisfy the while loop, it will exit the while loop, which is the reason why we need an end, and it will jump to this part of the command statement, which is stop moving the Pac-Man. And that's how while loop works. And these comments able to tell the user what their selection is really doing. So let's try the while loop itself. Click on this, and we want the Pac-Man to collect the first 5 dots in front of them, the pack dots. So we collect 5, and to collect them, you gotta move forward. So move forward, and then you press end because every while loop needs an end, and you want it to stop moving. Next, after you stop moving, you want it to turn right or turn left. You press the if and else statement. So if the vehicle is stopped moving right here, so we select if Pac-Man stop moving, we want it to turn right 90 degrees. And then you click on else, and you click on stop moving. And this else part is pretty much just in case this line of code is not executed properly. If it's still moving, you want it to stop moving. Other than that, this is how the advanced option works in this app. It's just a way to show how this the computer program look like, the layout and everything. So if the user is satisfied with all the code, the program they developed, and they feel like they have achieved the amount of tasks they want the Pac-Man vehicle to perform, they can press the compile button and it will compile. After compile, push the go button on the backboard, and they can watch the vehicle does its own performance. And that is it for this app prototype. The video you're about to watch is a keyshot render video that will show you how the Pac-Man move on the backboard.